Greetings to you all. Welcome to today's discussion. Today we have an interesting topic that we're going to discuss about. It's basically called active learning and the detection of anomalies in cryptocurrency transactions. So this is a topic that was researched and written by somebody in a journal. So I got it. So today we're going to talk about it and go through some of the different aspects of this research. And as you can see, the link is below. So in case you need to go through and read the topic by yourself, it's okay. So let's dive right into it. First of all, we're going to discuss the computational problem tackled by the authors. This refers to the detection of fraud behaviors in cryptocurrency transactions. So the authors basically came up with the problems that they handled. The first one being lack of labeled data. The authors identified the challenge of obtaining labeled data for fraud detection within financial domain, which makes it difficult to train effective supervised machine learning models using historical data. And then another aspect they talked about was the aspect of time and resource constraints, because they say when there needs to develop mechanisms that allow analysts to focus on their efforts on transactions most likely to involve fraud due to time and budget constraints faced by organizations in their reviewing transactions. Another aspect they discussed was the ever-evolving nature of criminal behaviors. As you know, when loopholes come into a system, criminals will always look for other ways of stealing, because once the current loophole has been repaired, they will always look for a different way, a weakness in the system. So they exploit it due to lack of regulation and anonymity. So from there, we're going to look at the machine learning models that were developed by the authors. The models developed in this research paper are primarily focused on active learning techniques for fraud detection in cryptocurrency. So they basically came up with the active learning strategies, which they divided into 6 different active learning query strategies. First one being unsupervised, second being supervised, and then the third one was query by committee and uncertainty sampling. These strategies aim to select the most informative transactions for labeling at each iteration of the process. And then from there, the second one they came up with was the supervised classifiers, which include 3 classifiers: random forest, logistic regression, and XGBoost. These qualifiers are trained on the available labeled pool at each iteration and evaluated on a test set. And then from there, we're going to look at the approaches used for model evaluation. The evaluation of the machine learning models in the article involves comprehensive analysis of performance metrics, comparison with baselines, examination of learning curves, and statistical validation of observed improvements. The first one they talked about was the performance metrics. They evaluate the performance of machine learning models using maximum F1 score at each labeled pool size. So basically, the F1 score is a common evaluation metric for binary classification that balances precision and recall. And then from there, they also talked about the comparison with baselines. The performance of active learning setups is compared against supervised baselines. The supervised are trained on the available labeled pool at each iteration and evaluated on a test set. The performance of each supervised classifier is compared against each respective baseline, providing a benchmark for assessing the effectiveness of all the active learning approaches. And then they also talked about the learning curves, which analyze the learning curves of each active learning setup, showing the evolution of the F1 score through different labeled pool sizes. And then from there, we also talk about the experimental setup. The active experiments are conducted using a predefined experimental setup, including specific AI strategies, batch sizes, and iteration limits. This ensures consistent and reproductive in the evaluation process, allowing for a fair comparison between different active learning setups and baselines. So from there, we're also going to look at the thought process of the authors. That is basically what they did and what they think can be done in the future. Essentially, explain the underlying rationale, reasoning, and decision making that guided their research, and this includes problem identification. The authors will discuss how they did identify the problem or a gap in the knowledge that their research aims to address. This involves recognizing the importance and relevance of detecting fraudulent behavior in cryptocurrency transactions and challenges associated with it. And then their methodology. They also describe the approach they used to address the research objectives. This includes explaining why they chose certain algorithms, techniques, and how they implemented them to tackle the computational problem of fraud detection. They also suggested future directions. Potential future directions or areas where they feel the research can be done further. This involves addressing limitations of their current study, exploring new techniques and algorithms, extending their research to different domains and applications. So basically, after talking about what they think, it's also fair that we discuss the strength of their research. And the first one was comprehensive evaluation metrics. The authors used the F1 score, a widely accepted metric for binary classifications task, to evaluate the performance of their models. And they also use comparisons with baselines. The authors compared the performance of their active learning setups against supervised baselines, providing a benchmark for assessing the effectiveness of the AI approaches. So basically, that was our discussion for today. Thank you for listening.